So today we're going into CIE 970113 for May and June 2019. This is paper 1. We're going into one by one on how to answer the question. We're going into straight question 1. Manganese and nitrogen can show a range of different oxidation states. Calculate the sum of oxidation state of Mn and nitrogen each row of the table. In which row is the sum the smallest? So first what we need to do is we just need to calculate the individual oxidation number. Let's go into the first row. So since Cl, the oxidation number will be -1, hence the oxidation of manganese here will be positive. So we have +4, and the nitrogen in its standard state is 0. And in the second row, all combined oxygen will have -2 except for in peroxide, and for carbon here we have a +4, hence you have +2, and for nitrogen in nitride ion. So since oxygen is -2, hence we have nitrogen as +3. So in the third row we have -2 for oxygen and +1 for potassium. Hence we have +6, and for nitrogen we have -3 since hydrogen is +1. And the last one has a +3 oxidation number since the hydroxide itself is -1. And here we have nitrogen as -1. So combine all the oxidation number state for each row. So the first row here, +4 plus 0, we have 4. And then the second row we have +2 plus +3, so we have 5. And on the third row, +6 plus -3, so we have a +3. And the last row, +3 plus -1, we have +2. Hence the smallest will be donkey. The second question, the mass spectrum of an alloy of copper and gold is shown. Which expression can be used to calculate the relative atomic mass of copper present in the sample? So in order to calculate relative atomic mass, we need to multiply the percentage abundancy with the M2Z value. And this value is definitely due to the gold. So we have only 63 and 65. This is the M2Z value for copper. So since the question wants copper, we only need to multiply the 63 with the relative abundancy, and then plus another isotope which is 65, multiply with the relative abundancy, and divide by the sum of the percentage for 2 of the isotopes. So in here we have C. The next one, which atom has exactly 3 unpaired electrons? So let's go into one by one. An isolated gaseous aluminium atom. So aluminium has 13 electrons, and we have 1s2, 2s2, 2p6, 3s2, and 3p1. Carbon has 6 electrons, and we have 1s2, 2s2, 2p4. For chromium, we have 24 electrons. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, and 3d5. Remember, chromium is a special case. And for phosphorus, we have 15 electrons. So 1s2, 2s2, 2p6, 3s2, and 3p3. So if we draw the orbital diagram for phosphorus for the 3p, so we'll have 3 unpaired electrons. Hence the answer will be donkey. Element W is in period 3 of the periodic table and has a solid white oxide X, which is thermally stable and has a very high melting point. It is slightly soluble in water, which will describe the structure and bonding of X. So when this oxide form is a white solid oxide, we can say that element W must be a metal. That means it's either group 1, group 2, or group 3, because the oxide of the rest of the group in period 3 will be a weak lattice or a gas. So it must be ionic. So there we can eliminate A and B. And since it is only slightly soluble in water, they must have a giant lattice. So the answer will be C. Number 5, ethane and fluoromethane have the same number of electrons in their molecules. Their boiling points are given. So ethane, because it only composed of carbon and also hydrogen, therefore it is non-polar. That means The strongest intermolecular forces between ethane will be London dispersion force. And for fluoromethane, because of the presence of fluorine, therefore it is a polar molecule, and when you have a polar molecule, the strongest intermolecular forces you will have will be permanent dipole-dipole. And as we know, permanent dipole-dipole is a stronger intermolecular forces compared to London dispersion force, which affect the physical properties of the molecules, for example the melting point, the boiling point. So here we can say that the difference in this boiling point is because fluoromethane has a permanent dipole-dipole where ethane does not. The next one, the reaction pathway diagram for a chemical reaction is shown. Which statement is correct? So you can see here, since the product has higher energy compared to the reactant, therefore this is an endothermic reaction, hence the delta H will be a positive sign. So the activation energy of the forward reaction and the enthalpy change of the backward reaction have the same sign, so this is incorrect, because the activation energy is positively in charge and the enthalpy change of the backward reaction will be negative. So the activation energy of the forward reaction is more than twice the enthalpy change. This is also incorrect. There is no significant relationship between the value of the activation energy and also the enthalpy change, which shows that the answer D also wrong. So the enthalpy change of the forward reaction and the activation energy of the backward reaction have the same sign. This is correct because both will have a positive sign, so we have C. What changes in condition or molecular properties make it more likely that gases approaches ideal behavior? So for gases, we have two. We have ideal gases and also we have real gases. So in order for the ideal gases to change into real gases, it will be due to the high pressure and also at lower temperature. So where at higher pressure, the particles are closer together, and at a lower temperature, the particles has lower kinetic energy. Hence, there will be intermolecular forces between them, which lower the expected pressure. So in order for it to approach ideal, it will be vice versa. So higher pressure will be wrong, lower temperature will be wrong, and when you have a more polar molecules, that means you will have a stronger intermolecular forces. So a stronger intermolecular forces will lead you to have more real gases. So it's strong as well. And the answer is donkey, because when you have a weaker intermolecular forces, hence the intermolecular forces is unlikely to happen between the molecules, therefore it will exhibit an ideal behavior. So ethanol can be oxidized to ethanol by dilute acidified dichromate 6 ions. The oxidation reaction is given. The reduction reaction equation is also given. So which equation is correct? To answer this question, we just need to add both of the oxidation and reduction reaction together. We only have 2 electrons here, so that means we need to multiply by a factor of 3 to give it 6 electrons. Therefore, we can cancel with the electron in the reduction reaction. So it will make us to have 3 ethanol, and 6 H plus, and also 6 electrons, which we cancel with the reduction reaction. We can also cancel the H plus from the reduction and also oxidation, so 14, subtract with 6 H plus, therefore we are left with 8 H plus, and the remaining will be as it is, so the correct answer will be A. 9. What is the correct expression for Kc for the reaction shown? So for Kc, you will have product over reactant, and the coefficient will be the power for that substance. So that means we will have I negative squared multiply with Fe3 plus squared divided by Fe2 plus squared multiply with I2. So from there we will have the answer as B. X and Y react together to form Z in a reversible reaction. Equilibrium yield of X is lower at higher temperature, which shows that the delta H for the forward reaction is negative, and the equilibrium yield of Z is lower at lower pressure. which shows that the right hand side has lower number of gas particles. So the answer is A, because on the left hand side you have 2 gas particles and on the right hand side you only have 1. And the forward reaction is exothermic. Question 11, we have a graph with 2 lines where P is for a reaction between 0.1 mole of magnesium carbonate with 50 cm³ of 1 molarity sulfuric acid, while Q is a reaction between the same magnesium carbonate but with a different type of acid. So which sample or acid could give the line label Q? So let's get into one by one. So let's get into the rate of reaction. So Q takes longer time for it to reach completion compared to P, which means that Q and P uses different acid. So from there we can delete A and B because here you are using the same acid. And from the volume of carbon dioxide produces, we can also see that Q produces more carbon dioxide compared to P, which means that more acid are used in Q compared to in P. So the answer will be donkey. The next one, sodium and sulfur react together to form sodium sulfide. How do the atomic radius and ionic radius of sodium compare with those of sulfur? So both sodium and also sulfur is on the period 3 of the periodic table, where sodium will be at the very left hand side of the periodic table and sulfur will be at the right of the periodic table. And we know that across the period the atomic radius decreases, which consecutively means that sulfur will have smaller atomic radius compared to sodium. So we can go ahead and delete A and B. So when these atoms react to form ions, anion, which is negatively charged ions, will have a bigger ionic radius compared to cation, which is a positively charged ion, due to the extra repulsion from the extra electrons. So we can say that sulfide ion will have a bigger ionic radius compared to sodium ion. So in this case, the answer will be donkey. The next one, which paragraph represents the variation in electronegativity for period 3 elements? As we know, across a period, the electronegativity increases and there is no deviation from the trend. So the answer is ball. The next question, dilute hydrochloric acid is added to solid barium carbonate and also solid magnesium carbonate in a separate test tube, which means here an acid reacting with bases. And the next one, we have dilute sodium hydroxide is added to barium chloride and also magnesium chloride in a separate test tube. So in this reaction, that means it will produce barium hydroxide and also magnesium hydroxide. As we know, down group 2, the hydroxide become more soluble. That means the reaction of barium chloride with sodium hydroxide will produce a soluble barium hydroxide, and the reaction of magnesium chloride with sodium hydroxide will produce a solid magnesium hydroxide. And of course, the reaction of acid and also bases will produce an effervescence of fizzing. So in that case, the answer will be C. So river water, it contains ammonium ion, carbonate ion, hydrogen carbonate ion, chloride ion, and also nitrate ion. So when we add it with calcium hydroxide, which will be precipitated. So from here, we just need to recap back on our solubility table. We know that calcium chloride will be soluble, nitrate will be soluble as well, and all with ammonium will be soluble. So in this case, the only precipitate will be calcium carbonate. So the solid sodium chloride and sodium iodide both react with concentrated sulfuric acid. So as an explanation for this difference in product, so as we know from group 17 trend, we know that the reducing capability of the halide increases down the group, which means iodide ion is a better reducing agent than chloride ion. So since iodide ion is better at reducing other substances, hence the sulfuric acid is further reduced into sulfur hydrogen sulfide. So the answer is C. An aqueous solution of calcium compound is treated with a mixture of dilute aqueous nitric acid and also aqueous silver nitrate. So from this statement, we know that this is a reaction to identify the type of halogen or the type of halide present. So from the reaction, the white precipitate dissolve in aqueous ammonia. That means the calcium compound must contain chloride ion, which consecutively we have identified that this calcium compound is a calcium chloride, CaCl2. So now we just need to identify the molar mass of the calcium chloride. So you may refer to your periodic table, and from there we identify that it has 111.1 gram per mole. The next one, which statement about the ammonia ion is correct? So the first one, it can act as a Bronsted Lowry base. It is not. Ammonium ion is a Bronsted acid. It can react with OH negative to give an ammonia. This is true because it is an acid. It is a pyramidal with bond angle of 107 degree. This is incorrect. Ammonium ion has 4 bonds, which means it will be tetrahedral in shape. And the nitrogen atom is sp2 hybridized. This is also incorrect. Nitrogen atom has 4 bonds, which means it will be sp3 hybridized. So the answer will be B. In a catalytic converter, 5.6 gram of carbon monoxide react with an excess of nitrogen monoxide. What is the product in this reaction? So first, what we need to do is we need to draw a balanced equation in the catalytic converter. You will have carbon monoxide reacting with nitrogen monoxide to form harmless nitrogen and also carbon dioxide. Hence, we just need to do some sort of a balancing equation here where you will have 2 mole of carbon monoxide, 2 mole of nitrogen monoxide, and also 2 mole of carbon dioxide. So from the information given, we just need to identify the mole of carbon monoxide. So in this case, 5.6 gram divided by the molar mass, which is 28 gram per mole. Therefore, we have 0.2 mole. So the ratio of carbon monoxide to carbon dioxide is 1:1. Therefore, the mole of carbon dioxide is also 0.2 mole. So from there, we just need to multiply with the molar mass of carbon dioxide to give the mass of carbon dioxide, which we have identified as 8.8 gram. So do the same for nitrogen. Since the ratio of nitrogen to carbon monoxide is 1:2, that means the mole of nitrogen will be half of the mole of carbon monoxide, which is 0.1 mole. And we multiply the 0.1 mole with the molar mass of nitrogen, which is 28, to give mass of 2.8 gram. Hence, the answer would be donkey. The next one, the Finkelstein reaction occurs when sodium iodide in propanol react with chloroalkane or a bromoalkane. The halogen is directly replaced by iodine. So in this case, this is a displacement reaction. So which halogenoalkane will produce compound X? So what we need to find is, we just need to find the structural formula that suit X, except the iodine could be chlorine or it could be bromine. The halogen that will produce compound X will be D, because you have CH3, CH3, so 2 CH3, which is this one, and then the CH part, this is a CH, and then you have CH2CH, so this is the CH2CH. We should have a substituent CH3 here, and then you have another CH2, this one, and the iodine is replaced with chlorine. The next one, the diagram shows the skeletal formula of compound Y. What is the empirical formula of compound Y? So from here, we can see that it has 4 oxygen, and we can also see that it has 4 carbon, because here 1, 2, 3, 4. And it is also identified it has 4 hydrogen, because here 1, 2, and we have another hydrogen here, and we have another hydrogen here. So since all atoms have the same number, which is 4, that means it can be narrowed down, it can be divided by the same factor, which is 4. So the empirical formula will be CHO. The next one, in polymer Z, every carbon atom in the polymer chain is bonded to 1 hydrogen and also 1 methyl group. So that means you have something like this, so it must have 1 methyl, 1 hydrogen. So So which alkene could be polymerized to make this polymer Z? So from this we can see that this is actually the monomer and the double bond was originally here. So that means it comes from butene. The next one, which compound would produce a carboxylic acid and a ketone when heated with hot concentrated acidified manganate 7 ions? So this is an oxidation reaction of alkene. So for A, if you break here, this part will produce carbon dioxide. And this part will produce an aldehyde and consecutively a carboxylic acid. So A is not the answer. If we break this part in B, both of these sides will produce an aldehyde and consecutively carboxylic acid. So this is also incorrect. If we break this part, so both of the sides will produce a ketone. Definitely this is not the answer. If we go into D, if we break this, so the right part will produce a carboxylic acid and the left part will produce a ketone. Hence, this is the answer. Number 24, water is added to a sample of 2,3-dibromohexane. So some of the 2,3-dibromohexane undergoes complete hydrolysis and some of it undergoes partial hydrolysis. By the term hydrolysis, that means this halogenoalkane will react with water to form alcohol. The product could be both of the halogenoalkane has turned into OH, or only one of it will turn into OH for partial hydrolysis. So from this structural formula given, we just need to identify which is not the mixture. The answer will be C, because as you can see here, the OH in this structure is actually at carbon number 3 and also at carbon number 4. But the OH should be at carbon number 2 and carbon number 3. Which statement about the mechanism of an SN1 reaction of halogenoalkane is correct? So SN1 is a mechanism for tertiary halogenoalkane to undergo nucleophilic substitution. Start of this reaction, only one molecule is present, which is the halogenoalkane, and this halogenoalkane will undergo heterolytic fission to form a carbocation as an intermediate. So from the options given, a nucleophile is substituted by an electrophile. No, this is incorrect. One intermediate is formed from two reacting molecules. This is also incorrect because there is only one molecule at the start of the mechanism. The intermediate is stabilized by the adjacent alkyl group. This is true. This is the inductive effect of the alkyl group. And the intermediate is uncharged. This is incorrect because it produces a carbocation which has a positive charge. So the answer will be C. In this next question, we need to consider both structural and also stereoisomerism. So we have 4 types of alcohol, and which alcohol will give the greatest number of different alkene when it is dehydrated. For A and for D, these are primary alcohol, which upon dehydration it will turn into an alkene where the double bond will be at the first carbon. When you have a double bond at the first carbon, there will be no stereoisomerism. Hence, A and D will produce only one product. So we can eliminate them. So if we go to C, upon dehydration, it will produce an alkene where the double bond could be here or the double bond could be here. If the double bond on the left hand side, it will produce 3-methylpentuene. And this 3-methylpentuene will have cis and trans isomer. However, if the double bond falls on the right hand side, it will still produce 3-methylpentuene. So regardless where the double bond is, the product will be the same. And we have 2 of those, therefore for C, it will produce 2 isomers product. For B, upon dehydration, it can produce double bond on the left hand side or on the right hand side. And on the left hand side, it will produce hex-3-ene. And hex-3-ene has 2 isomers, cis and also trans. And if it falls on the right hand side, the double bond, it will produce hex-2-ene. And this hex-2-ene also produce cis and trans. Therefore, in total, you have 4 products from B. Hence, this is the answer. The next one, compound Q react with 2,4-D and pH to give a precipitate. That means this compound could be an aldehyde or a ketone. So compound Q does not produce a precipitate when warmed with filling solution, which confirms that Q will be a ketone. So what could be the identity of compound Q? We just need to identify which one is a ketone. So this is an alcohol, so no. This is a carboxylic acid, no. This is your aldehyde, no. Hence the only answer will be A. Structural isomerism should be considered when answering this question. A set of isomeric compound with molecular formula of C5H10O all react with 1:1 ratio with an excess of HCN by nucleophilic addition. So from this molecular formula, we know that this could contain ketone and also aldehyde. And when it reacts with HCN, it will be producing hydroxynitrile. Since we need to consider the structural isomers, so let's draw all the structural isomers of C5H10O. So let's start with aldehyde. So we can have a straight chain aldehyde. We can also have branching aldehyde. Let's go into the ketone. So as you can see here, there are 7 structural isomers of C5H10O, which means all these 7 isomers will react with HCN to produce its consecutive product. Which also means that there are 7 isomeric sets in this compound. The next one, which pair of substance could react to give the ester? So as you can see here, ester is formed from a reaction between alcohol and also carboxylic acid. So we just need to count the number of carbon here. So for the alcohol, it contains 1 carbon. That means this is from methanol. And from the carboxylic acid, it has 1, 2, 3. 3 carbon, that means you will have a propanoic acid. So the answer will be C. The last one for this section, you have an ester. So what is the structure of the carboxylic acid that will be obtained by acid hydrolysis of the ester linkage? So if you divide here, this is the alcohol part and this is the carboxylic acid part. And in the carboxylic acid, it has 1 carbon. That means this is from your methanoic acid. So the answer is A. Let's get into this section. So which deduction about the 20983 bismuth atom are correct? So from here we know that this atom contains 83 electron, 83 proton, and 209 minus 83 we will have 126 neutron. So option 1 is correct. Option 2, this is incorrect. Option 3, so incorrect. So only 1 is correct, so the answer will be D. Next, which statement are correct when referring to the 2 common isotopes of chlorine? It has different masses, true, because they have different number of neutrons. They have different number of nucleon, which is also true. And they have the same chemical reaction, true, because they have the same number of electrons. All is correct, the answer is A. Which enthalpy changes the value of delta H always negative? Combustion, this is true. Hydration, this is also correct. Solution, not necessarily. So 1 and 2 is correct, therefore you have B. And next one, so we have Maxwell-Boltzmann distribution system. Which statement is correct? The shaded area represents the proportion of molecule with energy between E1 and E2 at temperature T2. Well, this is true. No particles have 0 energy at either temperature. Here the line starts at 0, so this is true. T2 is higher temperature at T1. This is correct because T2 is lower and also skewed to the right. So all is correct, the answer is A. Next one, which statement about sodium chloride are correct? It is a product when the reaction between chlorine and cold sodium hydroxide. Yes. It is a product when chlorine reacts with hot aqueous sodium hydroxide. This is true. And it is a reaction between chlorine and aqueous sodium bromide. This is also true. So you have A. Which gases will dissolve in water, causing lowering of the pH? That means it will produce an acid. So ammonia is incorrect because ammonia is a base. So you have 2 and 3 correct. So you have C. The next one, which compound have optical isomers? So you just need to find carbon connected to 4 different atoms. So in one, yes, it has optical isomers because we have carbon that is connected to 4 different atoms or 4 different groups. In option 2, this is also correct. We have carbon connected to 4 different groups. And in option 3, there is no carbon connected to 4 different atoms. So you have 1 and 2 correct. The answer will be B. Bromine react with ethene in addition reaction. Which statement about this reaction are correct? It is the basis of test for unsaturation of alkene. This is true because we see the color changes from orange to colorless. It leads to an increase in each of the HCH bond angle. This is not true. A nucleophile attacks C double bond C. This is incorrect because the C double bond C itself is a nucleophile. So the answer is D. The last two, we have unknown organic compound react with sodium to give a combustible gas as one product. That means we have production of hydrogen gas. It does not give yellow precipitate with alkaline aqueous solution. That means a negative iodoform reaction. What is the possible identity of Z? Well, all of these compounds will produce hydrogen gas when react with sodium, and it will have a negative observation for iodoform. Hence, the answer is A. The next one, organic molecule X. It has infrared spectrum, strong peak at 1250 and also 1720. That means it has a C double bond O, but without strong peak at 3100. That means there is no OH bond. So option C is incorrect because we have hydroxy. Hence, option 1 and 2 is correct. So we have B as the answer. Thank you for tuning in. Good luck for your exam.